Hello, welcome to Enlightning. I'm here with Tobin. We're going to learn about confidential containers today. Tobin, tell us about yourself, please.
Hello, I'm Tobin, and I work for IBM Research. I work at the Watson Research Center, which is just outside of New York City. Been here for almost 5 years. At this point, and
Yeah.
this whole time, more or less, I've worked on secure virtualization for the cloud, confidential computing, security stuff more generally. And I think I was at the very first meeting about confidential containers when it was just
Ah,
a seedling of an idea. If you scroll
yeah?
way down in our agenda document, you can see me saying
Yeah?
some really naive things back then. And I've
The
just
things I'm
been
going to say today.
hopefully it's slightly more refined what I'll be saying today. I've been really lucky to be part of this project as it's grown a lot,
Uh-huh.
and as we've driven towards this really ambitious goal of bringing cloud native confidential computing.
That's awesome. We have Kurmaju here saying hello from India. Hi, Kurmaju. Confidential containers. I've never heard about it. And I can relate. So I've been doing a whole series on Enlightening and on another show I host called You Choose about security. And then I've been doing like, okay, here's MTLS, like here are the service meshes, here's access control stuff, here's like secrets management stuff, and confidential containers. Like it's its own thing. I haven't figured out what other CNCF projects to even compare it to. So I guess we're getting into some juicy stuff. Like the problem that confidential containers is solving, I want to know very much actually, but I want to wait until I'm behind the light board to find out. So for now, it's just a juicy teaser. What I want to ask you, I'm interested in what it is like to work in a security lab because a lot of folks who come on are software developers, are like maintainers of the project, or maybe super users of a project. But you're a researcher. How's that different?
Yeah, that's a great question. I guess for me, research at its core is about sort of, I guess, creation of knowledge or propagation of understanding or something like that. So I think
Uh
it
huh.
fits very well with the open source world.
Uh huh.
It's true that we have maybe a slightly different perspective than the average engineer when it comes to just formulating a project. But I think, as you may see, that confidential containers is a project that has
Uh
a
huh.
lot of deep questions that need to be answered for it to go anywhere. And I think that's a good fit for researchers that like to stare at the wall and think about things all day long. At our office, none of the offices have windows in the lab, so it's the perfect environment for just pondering um,
Okay.
big trade-offs, trying to understand if some of these things are even possible.
Uh huh.
I think it's ended up being a really good fit for this project.
So what are your as a researcher? What are your deliverables?
Well, it depends. Different people have slightly different goals. Some people
Uh
are
huh.
supposed to write papers. I do not
Uh
have a
huh.
PhD, so thankfully I don't have to do that. I have published a couple.
You're actually punished for getting more education in that way.
It's really a matter of perspective. Um, but a lot of my colleagues are
Uh huh.
coming more deeply out of academia or whatever, and there's papers there. For everybody in research, though, I think the idea is to just to move the world forward and hopefully
Mm-hmm.
do that in a way that benefits the company. Um, discover new things. We're in the hybrid cloud division, so a lot of that for us has to do with enabling security in the cloud.
Mm-hmm.
Also, IBM is Red Hat and IBM are very closely linked these days, so a lot of it has to do with
Mm-hmm.
enabling development of Red Hat products that are already extremely widely used. Things like that.
Okay. Cool. Awesome. I want. I'm. So I've had one other. My Sig Store guest was also a researcher rather than a developer, and my Sig Store guest was also very secretive about their identity. He used his last name at least, but he doesn't have a LinkedIn. He doesn't have a Twitter account. Like it's hard to promote an episode with you. Not that no complaints, but I can't tag you in this stuff. That's all. What is there a connection? Okay, I'm gonna move behind the light board while I listen to your answer. But is there a connection between those things?
Deeply speaking, I don't think so.
Yeah.
But it is an interesting observation. There are
Uh
all kinds of
huh.
people everywhere. I mean, there's all kinds of people in research. Um, there's all kinds of people everywhere. But I do think that maybe there's some link. Maybe there's some some conclusions you could jump to about security research or something like that.
Uh-huh.
My lack of social media has nothing to do with security. Actually, my personal view on security is not maybe what you would expect, but maybe it's just that we happen to be really busy and don't have time for some of those things. I'm not sure
Oh yeah,
exactly.
I can. Okay, I'm sorry. The sound between the two places. This is a new setup today, so I can imagine that I like have read the book Deep Work that like you need to do really deep thinking, and social media is a huge distraction from that. Both while you're looking at it and running in your mind in the background when you're not. And so maybe you just do better work, and everyone would, regardless of what their profession.
It's not to say I don't waste a lot of time, but
Okay, I can't hear you right this very. Can you hear me? I don't know. I just need to figure out how to get to move my iPods over here. You can you hear me?
I think that's better.
You can hear me?
Yeah.
Okay. Here, I'm not the problem is everything's coming in and out of my computer itself and not my my AirPods, sorry. So let me just figure that out. I'm so sorry, this is boring. I want to respect everyone's time. Aha. Now, how about now? Here I am. And now I can do that from here. Sorry. So many things sitting. Okay. Can you hear me?
I can.
And I can hear you. This is wonderful. Okay. So now we're here and take their names off. Hello. We've done the transition. My last episode we had, speaking of respecting everyone's time, my connections, my ports in my old computer started failing. And so we disconnected from the camera 3 times during the stream. So in the last week, I've gotten a new computer and I just have a second dedicated computer to this episode, but I don't know like a graceful way to move from one to the other. Clearly, we'll figure it out together over the coming weeks. So we're getting into the juicy. So confidential containers, in your opinion, is there a related CNCF project or just like tool in general, regardless of whether it's CNCF?
Ooh, interesting question. So there are a lot of security-related things in the CNCF, some of which you'll see share some ideas, but also I think we'll come to understand why some of these things are a different approach than confidential containers. There are a lot of confidential computing projects out there in the world, a lot of clouds of different offerings. There are also Kubernetes-based confidential computing offerings out there from a couple of different companies. So there is some other stuff there, but it's fundamentally a pretty new field, and there's not a lot of other things.
Okay. I think well, I definitely want to ask you, like, what was the world like that caused confidential containers to get created? But you're using this phrase confidential computing that I already am not familiar with. So I feel like we need that context. They're probably kind of like 2 angles of the same question, right? How about just in general, give me some context that I need of what
Sure.
to understand confidential containers.
Yeah. Well, so let me put it this way. Confidential containers is around to make confidential computing, which is an underlying hardware technology that I can get into in a second, way more accessible. And before confidential containers, the reality was that confidential computing was really new, really non-standardized, and really low level. So, like I said, it's a hardware technology, and it's very difficult for people, especially maybe people who might be working at the level of the stack that Kubernetes lives on or that cloud native applications live on, you're going to have a hard time figuring out how to get confidential computing integrated easily into existing workloads. So that's what confidential containers tries to do.
So confidential computing. I have a question. Do these things have acronyms, or am I going to write confidential containers and confidential computing a million times today?
Well, they do have acronyms. The bad news is that they are the same. But we usually call confidential containers COCO, like COCO. And you could call confidential computing CC, I guess. But the difference between these two isn't super important. We'll definitely touch on what confidential computing is. But we'll probably just need to write COCO mainly, which is the short name of the project.
It's cute. So confidential computing was super new. And then it was hard to, did you say, like, is the right language integrate confidential computing capability in a Kubernetes environment?
Yeah, hard to integrate in any environment. But Kubernetes, definitely.
I am going to use this. We're going to make up our own acronyms here. Very, very cleverly. So confidential computing was hard to implement, hard to integrate.
All of the above.
Okay. So confidential containers specifically solves the problem of adding confidential computing capabilities to container orchestration software.
Well, to Kubernetes, you might as well say.
We could say Kubernetes. All right.
Yeah, sometimes we talk about it as being a standardization layer for confidential computing at the container level, or really at the pod level.
An integration layer at the pod level?
Yeah, or a standardization layer for confidential computing. You have at the pod level.
Okay. Into Kubernetes. Standardization. For adding confidential computing at the pod level. Is that correct?
Yep.
Okay. I understand everything except one of the major building blocks, which is what is confidential computing and why do we need it?
Yeah.
Before you answer, I'm curious, those of you in chat and also just like your experience, Tobin, like, is confidential computing something that's widely practiced?
It's an interesting question.
Yes, I would like you to weigh in on it.
The confidential computing is a new technology, fundamentally. There's definitely some parts of this technology that's still growing, right? That's still looking for people to integrate it, still looking for adopters or whatever. But the momentum behind it is undeniable. And I think shortly we'll touch on like what this hardware actually means, and we'll see that basically every major hardware manufacturer has moved to support confidential computing. Every major cloud is working on supporting confidential computing. There are some people who would tell you that it's going to be like TLS in a few years. It will be the de facto standard trust model of cloud computing. I don't know if it'll live up to exactly that prediction, but there's certainly a ton of momentum behind the technology.
And you would refer to confidential computing itself as a technology and not like a framework or something. It's a technology. Okay.
Well, it could be both, I guess.
Okay. I didn't know if it's like a way of doing things or if it's a specific tech.
Well, you need special hardware to do this. You need particular machines that have stuff built into the silicon to do confidential computing. It's a hardware technology. But it also is a paradigm shift in how software is thought about. So we'll get into that.
Okay, that has momentum, big momentum. So it's a paradigm shift and it needs new hardware.
Already, perhaps, you get a taste of why this is so hard if you're not using confidential containers.
We're probably jumping ahead, but does the confidential containers bypass the need for different hardware?
Nope.
Okay. Okay. So we have some context for confidential computing and some context for confidential containers and context for confidential computing. But we haven't said what confidential computing is still. And Kuramaju is taking a guess. Confidential computing is like a virtualization layer between hardware and VMs?
Sort of.
Those are the kind of answers I'm getting to, Kuramaju. I relate to you.
Well,
yeah.
we can strike to the heart of what it means.
Let's do it. Yeah.
So the most common definition of confidential computing is that it is for protecting data in use. This is a little bit abstract, like data in use, what is that? But really what we're getting at here is that we already know how to protect data when it's at rest and when it's in transit. So when data is at rest, you can put it in a bank vault or put it under your pillow or encrypt it would be a slightly more common approach. And when data is in transit, we have things like TLS, all kinds of secure communication protocols to protect data that's going over the network. Confidential computing is looking at a different problem, which is what happens when I actually want to execute some code. Like when I have an AI model that is supposed to be doing an inference on some data, and it's supposed to actually be running right here, is that data still protected? And without confidential computing, the answer is no.
Okay. That seems very valuable. So since we've gotten so good at encrypting data at rest and data in motion, really the most vulnerable spot is getting at it when it's running. And as part of like all this security I'm learning, there is the way I've seen it not solved, but the closest I've seen anything come to it is a cube armor. Do you know that technology?
I know a little bit about that.
Okay, so it's like runtime. It's able to watch all your system calls in runtime and do inline enforcement of policy that you create. But so that's like the closest I can think of to what you're describing to me.
Yeah. Well, let me give you an example here. If you today are using any managed Kubernetes service, you have Kubernetes, a cluster spun up in any major cloud provider, and you have every imaginable Kubernetes CNCF security project in use. So you've locked everything down as much as you can. At the end of the day, that cloud service provider still owns the machine that it's running on, and you are sort of just trusting, hoping that they're not going to go and look at your data, because there's no technical assurance whatsoever that the owner of the machine doesn't just look at everything passing through the node. That's a little bit of a simplification, but that's really the heart of what confidential computing will shift, is that it will give you an ability to run a workload in any cloud or whatever and have a technical assurance that there is no way that the owner of that node can access your data at any point, which is that is a huge shift.
Are cloud companies like shaking in their boots because if everyone moves to this model, all of their old hardware is now worthless? Or is it just like, nah, they're just going to charge people for it? It's like, oh, we have a new product upgrade.
It's still very early in the rollout of all this, and it's not clear what the dynamic will be. There are some workloads in which the level of security that exists now is no problem. I mean, obviously, lots of people run stuff today and they
Yeah.
don't care.
Like a,
But
mm-hmm.
there are also workloads that have not moved to the cloud yet because of things like this. There are a lot of regulated industries where the guarantees that you get with the cloud today are simply not strong enough. And so in theory, this will be sort of an additional option for people who have particularly sensitive workloads. But like I said, some people will tell you that it'll be like TLS, that it will be the de facto way that we think about cloud computing in the future. That looking back, it'll seem bizarre that we would have in the past just sort of put our workloads, up in the cloud without much protection.
By the physical machine owner. For example. So confidential computing is some sort of technology slash paradigm that is concerned with protecting data while it's in use.
Yeah. And you might think, how is that even possible? Like, surely the owner of the CPU has control over what's happening. I mean, let me also give you a very concrete example of a traditional container. So in a traditional container, which granted may or may not be the actual environment that a lot of these cloud-based container services are using, but traditionally, if you have like a Docker container, the kernel is, there's the actual container image itself. You may have a bunch of these, and they all share one kernel, which is the host kernel. So in this case, the person who owns the host kernel is constantly getting, syscalls being made from the workload to the kernel with all kinds of data, and they basically can see everything that's happening there. This is what I mean about the owner of the machine having a lot of insight into what's going on. And it's actually been pretty well proven that for standard containers, at least, if you own the kernel, you can manipulate the workloads to do basically anything you want to exfiltrate data. There's some very well documented attacks that show that this boundary is not secure at all. And so if you're running a container, you'd better trust the kernel that you're running it with, because they can see everything you're doing. Now, in real clouds, typically the way that containers are deployed is more sophisticated, and there usually is a virtualization boundary of some kind. But similar things are actually true about virtualization as well.
Similar things are true about virtualization. Like whoever owns whatever hypervisor layer is going to also okay.
Yep. I mean, fundamentally, even if you use a virtual machine, the person who owns the device can stop the execution of the VM, dump all of the memory, and read it. So
okay. That's yes. Okay, I'm convinced. Let's do it. Let me so do we have on the board a good definition? So confidential container solves the problem of integrating of integrating confidential computing into Kubernetes. So a standardization for adding it at the pod level. That is a good definition. Confidential computing protects data while it's in use is maybe a little simplistic, but maybe we'll give it a more complex definition at the end when we talk. Or is there more you want to add or say to confidential computing at this point?
Let me add two things.
Okay.
First of all, a little bit of a more concrete understanding of what this actually looks like. And maybe this will help answer the question from the chat a little bit. In practice, the way that confidential computing is usually implemented is as a VM that has extra protections. So it's still a virtual machine, but you have a stronger isolation boundary that prevents what we mentioned a moment ago, which is the owner of the hypervisor, the owner of the node, being able to just dump all of the information about the VM or manipulate the way it executes. Typically, this is implemented with encrypted memory, but there's a lot of variation here, and this is where we get into the non-standardization. And there are even confidential computing paradigms that don't use VMs, but we'll sweep those under the rug for now. So in practice,
we have one light board. So before I put in the in practice, I want to quickly say, like, it's hardware and it's I keep saying paradigm, but it's a strategy and it's it's hardware. It's a technology and it's a strategy.
Well,
I,
what I would say is that we have these hardware features, but confidential
uh-huh.
computing also implies a different trust model, right?
Okay.
The idea with confidential computing is that you don't trust the host anymore. You don't just hope that they're on your side and won't dump your data. And this has huge implications about everything else we're about to talk about. So there's a different trust model that comes with this. And that's sort of what I mean by the paradigm changing.
So we can say confidential computing is a trust model?
Well, it has a trust model that is different from a traditional one, but it is also
Okay.
hardware. I mean,
Has.
these are concrete hardware technologies.
Has a different trust model, but ultimately it is hardware. Okay. And then in practice.
In practice, it's usually implemented as virtual machines with extra levels of isolation that cannot be breached even by a host. Doesn't matter if you have sudo on the host. Doesn't matter if you go to the node, you go find the worker node in the data center, and you pull out one of the RAM chips, and you take it to your own computer and you plug it in, and you look at the memory, you won't be able to read it. So only the client, only the owner of the VM has access to it.
We have Fuel Snobbles here. Hi, Fuel Snobble. Thanks for coming. Oh, confidential computing sounds spicy. I think so too. I feel like a rebel right now. I just feel like it's pretty exciting that it's kind of exciting that to be learning new things and not like on the verge of a big change, right? Yeah, cool. So confidential computing has a different trust model. It is hardware, and in practice, it's usually implemented as VMs with extra layers of security that cannot be breached by the host. Cool. So are we going to tackle the complex world of how it works, or where do you want to take this next?
Let's go
Did you just look at your watch?
No.
Oh,
Let's
okay.
go to man. That'd be early if we were already. We've got a long way to go. So let's start with what somebody who is using confidential containers would experience, because it's actually remarkably simple what you would need to do today to turn this on. Simple if we make a few huge assumptions, like that you own the appropriate hardware, which you probably don't, but.
Okay, so the experience of using Cocos, and then should we write the assumptions first, or just?
Yeah, well, let's go with the. Sure, I would say the one big caveat is just that you need to some level, you need some form of hardware. Now, we will get to in a little bit what you can do with this project. If you don't want to have the hardware locally, you can use hardware in the cloud for this. So it's actually not anywhere near as big of a barrier as it might seem. But for the most simple examples, I'm sort of assuming that you have a machine with some sort of confidential computing support enabled. And just for the record, I will mention that would mean something like an AMD EPYC series machine or an Intel machine with TDX enabled, which would be something like Sapphire Rapids, or S390X on like Z17 as confidential computing. ARM, new ARM chips have ARM CCA. So there's a wide variety of these technologies out there. And we support all the ones I just mentioned, but you probably will need something along these lines. Although it's also worth noting that confidential containers has sort of a simulated mode where you can run all this stuff just to try it out without any of this hardware. But obviously, you will not get any of the benefits of this. But let's say that you have a machine of some sort. And again, we will in a little bit come to what to do if you don't have a machine and you want to use the cloud. But basically, it's actually extremely simple to get going with confidential containers. We have a Kubernetes operator that you can run on an existing cluster, and it will install all the artifacts and all the components that you need to use Coco. So step one is install the operator and wait for it to set up. And step 2 is to add a runtime class to your workload. And that's about it. At least for the simplest things. We will talk probably in great depth about how you would go about setting up more complex applications. But at a simple level, we have a runtime class. And actually, each of these different hardware types that I mentioned will have its own runtime class. So if you are on an AMD SEV S&P machine, for instance, you will just add a runtime class to your pod that would turn on the S&P version. And then your pod will automatically be run inside of a confidential VM, among many other things. But
Excellent. I'm afraid I'm using too much board space because he keeps saying, "Oh, we have so much to go into," and I'm like, "Oh, I'm already like halfway
you
through."
only have one board. This is it. Uh-oh.
But yeah, okay. I'll be. I'll try to be more choosy about what I write. But this is also great. All right. So the user experience of using Cocos is easy. So this is again similar to Sigstore, where we got kind of deep in it, but they're like, it's really easy to use, but here's how everything's talking to everything else. And similar, Build Packs was the same too, where we dug into how it works, but the idea is that you need to know almost nothing and you add a significant benefit.
Yeah. I mean, look, engineers love to tell you that it's easy to use. What can I say? But you get a lot of bang for your buck with sort of the Hello World example I've just explained. And you can see, I mean, it's a big difference from setting everything up manually. But we will also touch on what you really need to do to make an application that's truly secure and to handle a bunch of interesting cases. And we can do more depth on exactly what guarantees you get, all kinds of things. There's a lot of directions to go.
I'm excited.
There is someone asked in the chat if confidential computing has been used to support DMCA, and the short answer is no. Well, maybe it could be.
What is DMCA, please, for those of us uninitiated?
I'm assuming this is referring to like copyright enforcement of some sort. One thing that is worth noting about confidential computing is that one of the original use cases of confidential computing, like one of the very first things that people were using it for, was for DRM protection of protected content. So the idea here was that certain like distributors of media wanted to protect from, I guess, piracy, and they wanted to make it so that media could only be played, like it could only the media could only be decoded within a certain part of the chip or whatever, and that there'd be no way to like intercede and rip the media from the disk. That is one of the reasons why some very early confidential computing paradigms were around. That is not really related at all to what people do now. And I know that part of confidential computing, that's not really a great legacy to have, because nobody that I know, at least, is a very big fan of DRM or anything like that. But fortunately, the technology is not really associated with that anymore. But you might have heard about something like that, like almost a decade ago at this point. So that's worth noting.
Also, hello to Findle, who's here. Hi, Findle. Cool.
Okay, where do you want to go?
Well, we can. I don't know if you want to talk about how it works. I think that's very interesting. That's probably my favorite thing to logic out. I can guess and get things wrong all the time. We have live codings here too. Hello. But also like what you just said, like what are use cases for this? I mean, I guess what I would assume the use cases are the usual suspects for the super highly regulated industries, like anything that's handling PII or health data or financial data. How is that assumption? Is that correct?
Yeah, I think that's true. Regulated industries.
Okay. Yeah.
I think one place that could be good to start is to go back a little bit to the new trust model thing we were talking about, and to understand how that influences the thing that we built and developed. There's a couple of things that are really important to know, I guess, about confidential containers. I'm not exactly sure where to start, but we'll probably cover most things. I mentioned that this is at the pod level, right? that's actually a crucial design element of the project. And I'm going to try and be pretty concrete here and not too theoretical, but any confidential computing project faces a defining choice about what goes inside the enclave. That's, by the way, that's a term for like the confidential thing, the VM, often referred to as an enclave. People also talk about it being called a TEE, a trusted execution environment. Those are all the same thing. On ARM, they call it a realm, all the same thing.
So the confidential environment is okay.
The secure place, the trusted thing.
The enclave, realm. Those are like Dungeons and Dragons-y, and then trusted execution environment.
Yeah.
Okay.
So any confidential computing project is going to be kind of defined by what goes inside the enclave and what goes outside the enclave. Things inside the enclave are trusted, basically. Things outside the enclave are not trusted, is the gist of it. It's not quite that simple, but that's the basic idea. And most software in the world was not really designed with this distinction in mind. This idea, we might trust some part of it, but we might not trust other things, is often not considered at all or not very rigorously formulated in a lot of software, Kubernetes included, turns out. So it's not an easy choice at all to know what goes inside of it. Let me cut to the chase here and say that confidential containers puts the entire pod inside of the VM. So it encapsulates one pod into one virtual machine, one confidential virtual machine.
Okay.
There's some interesting things about this. One thing that's sort of important is that the control plane, the Kubernetes control plane, is not inside the enclave, you might have noticed. So in confidential containers land, it's not trusted, which is interesting.
Yeah. So confidential containers puts each pod in its own VM.
Yep.
Control plane is not in there.
Yeah.
Kubernetes control plane is not in there.
A couple things to maybe mention as well is that to do this VM encapsulation of pods, confidential containers uses an existing project called Kata containers, which is a pretty big project. It's an open infra project, I think. Not a CNCF project, but it's a pretty widely used thing. And that's a project that takes pods and puts them in VMs. So we leverage that to take pods and then put them in confidential VMs. I won't get into exactly the differences. There are a lot of things that have to change and have to be tweaked to make this work. But
is it KATA, Kata?
Yeah. Yep.
Okay.
So that's a big key word for people to know about this project, is that it's very tightly linked to this Kata containers project. So
okay.
Yeah, that means that we pull your container images inside of the VM. So you can use encrypted and signed container images. Those are usually big tenets of confidential containers workloads, is that you use an encrypted or a signed container image. That's not included in sort of the Hello World example that we mentioned, but that's probably something you would build on top of that. You use encrypted signed container images, and you pull them exclusively inside the VM. So these things are unpacked inside of the VM and are not exposed at all to the host, which is not trusted.
But so there is communication still between like the kubelet and the pod. It just has to go through this trust boundary, this VM. Yeah.
Yep.
Should I be drawing a diagram, do you think?
You could. We have a couple of diagrams out there but yeah, you could take a crack at a diagram of a pod inside of a VM, different containers there, and you're totally right that there has to be some level of communication. And in a lot of ways, that's kind of the crux of figuring out how to build this thing, is understanding, well, wait a minute, we want this thing to be really isolated. We want it to be really like statically configured and secure and measured. We'll talk about attestation and measurement, by the way, later, probably. Turns out it's very important in confidential computing for the thing you're running for you to know exactly what it is. So we want this thing that's like really static in some ways and measured, but also we want it to be compliant with Kubernetes, that wants to start things and stop things and move them around and do all this stuff. How the heck
And
do you
shut them
balance
down
those?
and bring them right back up. Yeah.
Exactly.
Yeah.
How do you balance those things? And what communication is needed ultimately between like the kubelet and ultimately the thing inside of the VM that's going to actually handle all of this? That right there is that's the design space of the project.
So we have some questions from Fuel Snobble. Um,
Yes.
so one is, let me pull it up. So I got lost in my SQL Server. People talked about encryption being applied not only storage and transfer, but also during compute. Is that related?
Yes. So you could do this with confidential computing. And one use case of confidential computing, for instance, and actually there was a demo, I think, at KubeCon last year. I forget exactly what this demo was of using confidential containers to run a cluster that was running a Spark server. So you could have a database, for instance, where all of the like database workers are confidential VMs. And that means that when I go to like upload stuff to the database, it'll be completely protected when it's in the database. And no matter what cloud or where that's running, they won't be able to access that data under any circumstances. So there's a couple different database integrations.
Is there a big compute cost that comes with confidential computing?
Great question. Great question. So anytime you're talking about security, you should be worried about your performance, probably. Confidential computing is really designed to minimize the overhead. And like I said, it's a hardware technology. So there's some very specific hardware built, in this case, usually into the memory controllers on the chip itself, that allow you to do things really fast. So for most like operations, like reading and writing to memory, you would expect an overhead in the low single digits, which is extremely usable, especially when you're talking about the benefits that you get for now being able to run your workloads in a cloud or something like that. In truth, the full picture of performance with confidential computing is extremely complicated. And I won't be able to get into all the details. For instance, there is support for using GPUs with confidential containers, or confidential computing in general and confidential containers. Okay, very complicated topic. And, the overhead you might get from a GPU, extremely complicated and in flux. So I won't go into all the details, but essentially, we would not be doing this project if we didn't think that the overhead was manageable. And not just manageable, but actually quite favorable for security sensitive workloads and even performance sensitive workloads. But that's not to say that there aren't a lot of interesting trade-offs. Some of them we might.
Okay. Cool. So the short, I like what you said. Like if it was if it was too high of a trade-off, then this project wouldn't be a viable project. So it's something that's reasonable, but there are trade-offs to consider. And Spiel Stumbles has a lot of great questions.
I can speed run these questions really quickly.
Okay.
So container image signing for confidential containers uses existing image signing stuff that is already supported in like OCI images. And there are different ways to do this. Like you can use SigStore. We support SigStore for signing your container images. And you could do that with some like third-party CA, or you can sign them yourself. We have an architecture that provides you, for instance, the public key to verify the signature based on an attestation. So you only are able to verify the signature if you know you're in the correct VM. We'll come back to attestation in a little bit, but the short answer to your question is that you can do either one.
Cool. Does it have to be a signed image to run in a confidential computing?
You can run any container image. We would recommend that if you want your thing to be secure, it might make sense to use a signed or encrypted container image, right?
Yeah. If the whole goal is security, it would be a little bit silly to jump to confidential computing without doing the signing. That makes sense to me.
Yeah. And then I don't understand this watt overhead thing. Maybe we covered already. There's a question. So the memory is encrypted, but what about the internal caches and CPU registers? So yeah, this depends a little bit on the specific hardware, but generally most confidential computing also protects CPU registers. So for SEV, for instance, the SEV ES feature, which is the second generation of SEV, ES stands for encrypted state. And every time there is a world switch, like a VM exit, you take your current CPU state and encrypt it, so it is not exposed to the guest. There's a separate handler that will propagate very particular CPU values that are needed for virtualization via something called the GHCB, guest hypervisor communication block. Anyway, this may be too detailed of an answer, but the short answer is that yes, CPU state is protected. Internal caches is a slightly different question, but I'll just say that yes, that's not really a problem. Those are, yeah.
And then Fuel Stumble clarified his watt overhead question. Fuel Stumble was a guest on the show, so I know he's a he, him. But basically, he means a power overhead.
Yeah, interesting question. I think that it would basically be in line with the performance overhead that I was mentioning earlier. Yeah. So.
And yeah. And then Fuel Stumble, your comment here is something we kind of talked about at the beginning of the show, like for cloud providers, implementing confidential computing, if it takes whole new hardware, it's going to greatly impact cloud providers, whether it's a opportunity for a cash cow for them, probably.
Yeah. Well, when you talk about regulated industries, you're talking about laws. Like it's not, banks don't just sit around and think, oh, why don't we just make our thing way more complicated? Like this thing works through legislation. And there are actually already, particularly in Europe, there's legislation talking about things that would very strongly imply confidential computing. Obviously, it's a long and complicated process to map, like some law gets passed in the EU. What technology does that mean? That's a very complicated thing. But this is one of the potentially really big boons to confidential computing in the upcoming years. It's legislation that will strongly imply that you should be using it, both in Europe and in the US.
I think there's legislation recently that any software used by the federal government has to be accompanied with a SBOM. It doesn't say that anyone has to do anything with that SBOM, but get there in the first place. So this confidential computing trust model, you defined by what goes inside versus outside of the secure place, the enclave. And then Coco does this by putting each pod in its own VM. With the control plane's not in there. And we talked about a project called Kata. Do you think there's more I need to say about the trust model generally?
Well, let me say one thing. Let me introduce attestation a little bit, because it's relevant here. But we won't go too deep on this. I'll just say that what we've talked about so far is mainly isolation, right? Making it hard for someone to get inside the VM. Also makes it hard to get out of the VM, which is another sort of benefit of these things. So not only is this a protection against a host, but also it's a protection against other tenants, things like that. But isolation is one half of confidential computing. So we should probably mention the other half, which is attestation. And what attestation means is that you should know what is actually running, right? So
you as the software owner, as the system owner?
The owner of the guest, let's say.
What's the guest?
The VM.
The VM? Okay.
Yeah. So this is actually a very interesting question of terminology right here, because in confidential computing, the trust model usually is defined by the guest and the host, right? There's two parties. Not exclusively, but that's typically how people talk about it. When you show up in cloud native land, people want to talk about a lot more people. Software providers, code owners, the list goes on and on.
Administrators versus infrastructure providers versus,
So one of the big questions for this project, I mean, some of the work we're trying to do is understand, how do all these parties relate to a host and a guest? So I may hand wave through that a little bit at times, but yeah, typically there'll be at least, we're talking about the owner. That's going to be the person who's a VM. It actually is the person whose workload it is, the person who does not want to trust the cloud.
So you did say you could have a confidential computing environment without running signed images. So if the confidential computing trust model involves the owner of the VM knowing what's running, what's the difference?
Yeah, no, this is a great point. So let me first of all give a little bit more concrete detail about attestation, and then I will come to why ultimately you should use signed images, and why if you don't do something like that, you're sort of contradicting the idea of attestation, right? At a hardware level, these confidential virtual machines typically give you some mechanism for measuring exactly how the VM starts, like the initial guest memory state. Now, again, this is sort of low level. so that you can measure the registers that you start with, the guest memory, things like that. Point is, you know exactly what's running. Some platforms also provide you runtime measurements that can be updated while the guest is running and cannot be tampered with by the guest or the host. They're rooted in the hardware itself.
Okay.
These measurements are typically used to provide some sort of report of what your guest is, and this report is signed by the hardware generally, and this is typically backed by a pretty long certificate chain that will prove to you, if you get one of these reports, that it is generated by a real machine, and that it belongs in a particular cloud, maybe, and that it, there's no way it could have been tampered with at runtime. You basically get this signed thing that says, here's exactly what the guest is. And
so the thing that's being attested is the secure place.
Yeah, it's the VM, the enclave, the T.
Okay, that's, I think, okay. So the thing that's being, so the owner of VMware is knowing what's running, the VM is knowing what's running. It does not just, it knows everything about the VM itself, and then also knows whatever software is running on it. So, but when we say what's running, we mean everything about the VM itself.
Yes.
Okay.
And like I said, this is, it gives you like a measurement of the initial guest memory. So it's a pretty low level understanding of like what's running, but it's really like, this is how your VM started. This is exactly what it was.
Is that still on the board? Yes. Okay.
Anyway.
So attestation attests that the secure place is secure?
Yes.
Okay.
It gives you evidence. Like I said, you get some sort of report or something like that. This is signed. This evidence is what you should use to verify that your workload is good. And you should check this evidence before you deliver any secrets to your workload. This is the bow around confidential computing. This is how it works. You start up a VM somewhere, and then before you give it any secret information, before you give it your valuable stuff, you check the attestation report to make sure that it's correct. And you get cryptographic proof of exactly what was running inside the guest. So when we use encrypted container images, for instance, we don't give the keys to decrypt the container image to the guest until we do an attestation.
Okay, so I tuned out a little bit of the last thing you said. I'm sorry. I was thinking about how isolation and attestation applies here. So isolation is the secure place, whatever it's called, and then attestation is the evidence that the secure place is secure.
The walls of the castle is the isolation, and knowing who's inside of it, I guess, is the attestation.
Oh, makes sense. I like that. Isolation, attestation. Okay, and then you were saying something about steps.
Well, so if you use an encrypted container image, for instance, we give the keys to decrypt the container images to the guest only after an attestation is complete. Any secrets that are given inside of the guest happen only after an attestation. And this is probably the number one thing we left out of the Hello World example, which is that if you're using confidential containers, you're also probably going to be using another tool, another service to make sure, it's going to be a trusted service that will make sure that the guest is legit and will distribute secrets accordingly. So we can come back and talk about that a little bit. But let me get to your question, which this is sort of a circuitous answer to. If you don't use a signed or encrypted image, then essentially what you're doing is starting up this super secure, enclave. You're measuring exactly what goes inside of it, and then you're just running, I don't know, who knows what. You're just pulling some random image inside of it. This is not very smart.
Off the public internet.
Yes. You should use
a 1337. I will get you that image.
You should use a signed image or something like that, because it guarantees the integrity of your whole workload. And if, let's say that your workload is something like process everybody's social security numbers or something, right? You want to make sure that the container image that's going to do that is what you think it is. So you should probably use a signed image or something like that.
Yes. So when the secure place, is that also, so, okay, this term guest is new to me. So a little bit of, so the guest is the VM in this case that's running on the host, and that's why it's a guest. Can a secure place also be called a guest?
Yeah, same thing. So,
Okay.
like I said, we are mainly today talking about VM-based confidential computing. There are other paradigms of confidential computing that do not use a VM. So it's not
Okay.
true that a T is exactly equivalent to a virtual machine.
Okay.
And actually,
Okay.
confidential containers supports this other paradigm as well. But for our purposes today, we could say that the guest will be a confidential guest. So the virtual machine will be the T. Same thing.
Okay. Cool. After guest is attested. You come to a party, you're the guest, you have to prove that you're you and you're trustworthy, then you can have some hors d'oeuvres.
Something like
But
that.
not before. Yeah. Excellent. Cool.
Okay, so there's different places we could go. It might be good to talk about, like I said, our Hello World example left out the component that handles the attestation. So that might be good to talk about.
The component that handles the attestation.
Yeah. Well, so I was saying here that, your guest starts up, you validate the attestation, and then you provision the secrets. Well, when I say you in this case, who is this, and how do they do it?
Before we go into the component that does it, can we maybe talk about all the components at play?
Sure.
But does that make sense? So we're talking about components of Cocoa or components of confidential computing, which
now I think we're talking about confidential containers, really. Because if you just use confidential computing yourself, you're on your own for most of this stuff. And all these hardware platforms work a bit differently. So you really have a lot of messing around that you'll need to do much of anything. But with confidential containers, yeah, we have a handful of components that combine to standardize all this stuff and deploy these workloads relatively easily for you.
Okay, let's go over the components.
Okay, so let me first talk about Kata a little bit. So, like I said, Kata is a project that encapsulates pods into VMs. So the first thing we know that we're going to have somewhere is a virtual machine. And we know that there's going to be, our containers are going to end up living inside of that. Now, the way that Kata works is that it is an OCI runtime. So it is basically a stand-in for something like Docker. Instead of, I'll let you draw your arrow.
Thanks. Kata encapsulates unring. Is the thing that encapsulates containers into VMs, right?
Yeah. And the way that this works is that it is an OCI runtime. So it basically slots in place of Docker, or not really Docker, but in place of run C would be more accurate.
Okay.
So if you were using just like standard off-the-shelf Kubernetes today, you would probably be using like traditional, Docker containers that are orchestrated via, or that are set up via run C. So there's the kubelet, and then there's something like containerd. So kubelet CRI API talks to something like containerd. OCI API talks to something like run C. And Kata has two components. One of them is on the host, and this is the Kata shim, or the Kata runtime, and this is a replacement of run C. And then the other, that will, when the containerd is like, hey, I want to start this pod. Actually, containerd doesn't know about pods, but it says, can you please start this sandbox and these containers inside of it? The Kata runtime will say, okay, the first thing I'm going to do here is start a VM, right?
Okay.
And it'll use some hypervisor like this. Kata supports a bunch of different hypervisors, QEMU, Cloud Hypervisor, Firecracker even. So it'll start a VM, and then there's a second component that's the Kata agent that's inside of the VM.
Okay. So what's the first one's called the Kata shim?
Yeah, that's on the host.
The Kata shim, and by host we're talking about like the host machine, and it's interacting with the kubelet through, it's probably has a CRI interface, a container runtime interface to interact with kubelets.
Well, container
Okay.
D is in the middle, but essentially yes. The
Okay.
Kata shim is an OCI interface.
Okay.
But
So
essentially, yes.
Kata shim's on the host, and then it knows and then what's it receiving and what's it outputting?
Well, it will receive stuff like, hey, make this sandbox, hey, set up this container, hey, start this container. And it will basically start a virtual machine, and then it will forward. It does a bunch of other stuff too to facilitate all the resources of this VM, but it will start a virtual machine, and then it will basically forward these requests to a thing inside of the virtual machine called the Kata agent, and then that will be used to download the containers and start them up, things like that.
Okay, so it receives a request to do something with the container, and what it actually does is something with the VM, and then it forwards the request to the container in the VM.
Yep.
I see. On the host. Receives container requests, makes a VM, forwards container request to something inside the VM. Into VM. And then we have some sort of Kata agent inside the VM that's receiving these container requests.
Yep.
Is that correct? And what's that one called?
That's the Kata agent.
Kata agent. And VM receives your container request and then does whatever.
Yep.
Does whatever is the technical. Cool. So create, update, delete kind of stuff, probably.
Yeah, among other things.
Okay, we'll just leave it at does whatever.
Yes.
Example CRUD.
This, by the way, you can use Kata without confidential computing and without confidential containers, and this part we've just described would work the same way. So you can use it if you just want to take a pod and put it inside of a VM that's not confidential. Same thing.
Okay. Does Kata always do the one-to-one, one container inside one VM thing, or is that a confidential container thing?
One pod inside one VM.
One pod, yes, sorry.
Yeah.
One pod inside of one VM.
It is a pod-centric, as we like to say, approach. And I will mention that it's actually a very interesting question. What is optimal? You could put one container inside of one VM. You could put the entire worker node inside of one VM. Which one should you do? Well, this is a very interesting question, and we have determined that we should do pod-centric. If people are curious, we could talk about why that is more. But it's sort of a big question.
Kurmash, you had the same question as me. You already answered it, but like for each pod, do we require a new VM? And the answer is yes. And that's something that happens that Kata does anyway, or that's not confidential computing specific. That's happening at Kata level. Cool. So we have those virtual machine, Kata shim on the host, and then Kata agent in the virtual machine.
Yeah. There's a few more pieces.
One container in the virtual machine must be one of the things.
Yeah. So you'll have some sort of containers that'll run inside the VM. And
why did you say plural?
Well,
it's one workload container, but there are other containers.
You could have your pod could have as many containers as you want. So you could have tons.
One pod in the VM.
Yeah.
Okay, got it. Okay, and what else?
So one of the places that we diverge from Kata is that Kata containers, if you don't use it with confidential computing, will pull the container images on the host machine and use file system pass-through to send them into the guest. And obviously, this does not work for us because we're trying to protect the container images. So we don't want to pull and unpack them on the host. Typically, like Container D will do that for you. So we have a couple of components that that help us get around this. We have one more thing on the host, which is a snapshotter. So we have our own custom snapshotter. that intercedes in containerd's process of going to pull the image, and it says, no, you don't want to pull this image on the host. And it then connects to something inside of the guest, which is called ImageRS, which is a library that we developed that pulls and unpacks the container image in the guest. So there's a snapshotter on the host, and there's ImageRS in the guest. And those things handle container images.
I have a few questions. I haven't heard this word snapshotter before. Will you explain that to me?
Yeah, so a snapshotter is sort of a maybe slightly lesser known feature of like containers, where you can have snapshots of your container. And it's a little bit misleading to talk about the snapshotter here because we're not using the snapshotter to have snapshots of a container, which is basically a snapshot is typically like, oh, here's a view of a particular container at a particular place and time. But we don't really use it for that. The reason we use a snapshotter is because containerd checks if it has a snapshot of an image before it pulls the image. We don't want to pull the image on the host, so we say, let's implement a custom snapshotter, and that will hook into containerd at the right time to say, oh, actually, don't pull it. I already have the snapshot. But what it's really doing when it does that is going and talking to ImageRS inside the guest and saying, oh, please, can you download this container image?
Okay. So that makes sense to me. And then my second question is, how does the container get the image get inside in the first place? Like, where did it magically materialize from?
It's downloaded from inside the guest. So your guest will have a network connection and can connect to a registry, and you download your container image there. Now, I will just say, a side note for people who are thinking about this, this is there's a lot of interesting trade-offs here. And it turns out that actually pulling your container images inside the guest has problems. Typically, Kubernetes pulls things on the host because it gives you good like caching capabilities, right? You don't have to pull the same container image a whole bunch of times. With confidential containers, you pull it inside the guest, and there are some caching problems that can emerge. Like if you run a whole bunch of pods that have the same container images, you don't want to pull the same pod every time. The registry will get mad at you for pulling the pod too many times. You use too much guest memory. There's a lot of interesting trade-offs here. So we are also working on an approach where you actually do pull the container image on the host, but you do it securely. And this is extremely complicated, and we won't get into it here. But I will just say that what I'm saying here about pulling inside the guest, there's a lot of stuff behind that. That's from a security point of view, just understand you got to pull it inside the guest for it to be protected. But there's actually some interesting trade-offs, and there's some ongoing work to improve the way that this all plays out. So just a big asterisk on that one. But yeah, we pull the image inside the guest. So we download it from the registry inside the guest, and we unpack it inside the guest, decrypt it, verify the signature inside the guest.
Okay. So we repeat the components then, now that I have a better understanding of what's happening.
Sure. So, and there's one more component there's two more. Well, we got a lot of components, but we've got most of them.
We'll start going this way.
What happens when you want to start a pod? Okay. You're sitting there on your laptop. You run kubectl apply -f mypod.yaml, possibly .toml. You never know. It will then talk to Kubernetes. Okay, we'll skip all this bit and just say, okay, now we've shown up at the kubelet on the worker node, right? The kubelet on the worker node is going to be thinking, okay, I need to set up a pod here. And it will then talk to containerd, and it will say, hey, can you start a sandbox with some containers in it? That's what the CRI equivalent of a pod is, essentially. And then it will talk to the kata shim, right? So normally, it would maybe tell run C, hey, start these containers. Instead, we'll talk to the kata shim, and the kata shim will say, okay, well, the first thing I'm going to do is start a virtual machine. So we'll start that up. And then inside the virtual machine, the kata agent will start up. It's the init process in the VM, so it'll always run first. And it will use there's an API between the two. There's a gRPC connection. And the kata shim will say, okay, kata agent, here's the containers I'm supposed to start up. Okay. Also, I guess I sort of forgot when containerd was going, it says, oh, here's the container image I'm supposed to start. Well, let me check if I have a snapshot of this image. And when it checked that, the snapshotter actually said, okay, I'm downloading that inside the host. Right. Okay. Inside the guest. So sorry.
Downloads the image inside the guest.
Yeah. So by the time that you get to the kata shim being asked to run the create container request, the container has already been pulled inside of the guest. So then it goes and asks the kata agent, oh, can you go unpack this thing? And it will go set up your container, and then eventually it'll run it.
Okay. I'm so with you. But didn't you say there was another one that went with the snapshotter?
Yeah, that's ImageRS inside the guest. So
Okay.
maybe I skipped over that when we did the latest run through. But yeah, the snapshotter will talk to the container D will trigger the snapshotter. We'll talk to ImageRS inside of the guest, pull the image, and then the cat agent will start the image, start the container.
Oh, okay. So okay. So when I wrote the snapshotter downloads the image inside the VM, it's not the snapshotter that does that.
Well,
It's
not directly, but
okay.
it just talks to something inside the guest that asks.
Okay.
And that thing is called ImageRS. The RS,
Okay.
by the way, stands for Rust. So in this project, we really like the Rust programming language, which is a lovely programming language. And hey, if you're looking for a project to contribute to, you should come to Confidential Containers just for the Rust alone. It's a good time.
Okay. So I'm going to tell you my honest opinion is I wish that instead of listing them, I was, I guess, bringing them up in the story context that you're giving it to me. But so that's what I'm thinking about now, how to best tell the story with also the components. So the snapshotter just talks to the snapshotter tells ImageRS to download the image. Okay, and then Cormaggio has a question. What are the features we need to look at to buy a processor and RAM to make the confidential infrastructure? So how do we find that confidential hardware?
Yeah, so almost every major hardware manufacturer has some sort of confidential computing offering. If you are on Intel, it's called TDX, or there's also something called SGX, which is sort of a precursor. On AMD, it's called SEV. SEV SMP is the most recent version. So if you're in the market for a server, look for those features. In particular, it's Sapphire Rapids on Intel, where that's really been introduced, where TDX has really been introduced. That's Sapphire Rapids is very new. On AMD, this stuff has been around a little bit longer. So if you have an EPYC machine of any generation, I think, so Naples, Milan, Rome, Turin coming out soon, I think, then you're good to go. ARM also supports this stuff. S390X also supports this stuff. That's Z. Yeah, other platforms as well. But yeah, SEV or TDX. That's probably the main things to hone in on. I should say, I promised you guys that we would also talk at some point about how to run this on a cloud if you don't have the hardware. So maybe we'll get to that at some point. Hopefully we will.
Yes. We'll at least talk about it, whether or not we write it down. How's that?
Yeah, we may run out of space.
So the story you told, I feel like is not captured, which hurts me a little bit, but I don't know how to do it except maybe to draw pictures, but it seems like you want to talk about other things, which I'm okay with.
Yeah, I mean, a diagram is very useful, and there are good diagrams for this project, like on the GitHub and such. So I would recommend if somebody's watching right now and just like scratching their head or something, it does help with a picture. There are components. We didn't even touch on all of them. But yeah, the flow is somewhat straightforward to understand if you were looking at a picture, I guess. So
the important takeaways are that Kata does the work of encapsulating the pod in a VM. And then there's some oh my God, wow, that's new to me. And then the Coco is doing some work to make sure that image is being pulled from within the VM as opposed to from within the host. Whatever that work is, we don't need to worry about. And then is that the defining thing of confidential containers, or is there more to it?
That is a large part of it. There are a ton of details, and there's one other theme that's probably worth mentioning, which is the attestation stuff, right?
Okay.
So let's say that you have pulled an encrypted container image. Well, you need the keys inside of the guest to decrypt the container image, right? So how do you do this? Well, this is where attestation comes in. And inside of the guest, we have two more components that handle attestation. And one of them is called the CDH, which is the confidential data hub, and the other one is called the attestation agent. And you can sort of think of those as the same thing. But these two components inside the guest basically do everything that a guest needs to do to get hardware evidence. And then they set up a secure connection with the guest owner, we might say, with the client.
What's the second thing? The confidential data hub and what else?
Attestation agent.
Okay.
The CDH and the AA.
Okay.
And don't ask me why there are two and how they relate to each other, because it's a really long story. But
okay. So, and they work together to do what?
Well, to do everything you need to do inside the guest to get hardware evidence, right? That measurement of the guest we talked about. And they will do this for whatever platform you're on. They'll automatically detect what kind of guest you're in, and they'll get the evidence. And they'll use that to set up a secure connection with the other big part of the project, which is the components that actually handle the attestation and distribute the secrets. And it's kind of a shame because we're in the process of renaming those components. So I'm hesitant to even to jump to anything. But for now, we can call that the KBS, which is another big thing we should introduce here. The KBS, that stands for Key Broker Service. And this is outside of the guest. This is also not on the host. This runs in some trusted location, and it operates on behalf of the owner of the workload. So in some ways, this is really the root of trust of your workload, and this is the thing that's going to own your secrets. Now, it can be integrated with like a KMS or something like that if you want to store your secrets in some third-party key management thing, Key Vault or whatever, you can do that. But the KBS is in charge of getting evidence from inside the guest, receiving this evidence from the attestation agent, and determining whether or not the evidence is valid, and if it is, releasing the correct secrets. So in the case of our encrypted container images, ImageRS inside the guest would go to pull, would go and pull this container image, and it would realize, oh, this is an encrypted image. Okay, I probably need some keys to decrypt this image. So it's going to then ask the CDH, Confidential Data Hub, the hub for all confidential data. It'll say, oh, CDH, do you happen to have any keys to decrypt this container image I have? And the CDH will say, oh, okay, well, if I am going to give you a secret, then we have to prove who we are here. And it will ask the attestation agent, oh, can you get me some evidence, some hardware evidence? And it will use this to set up a secure connection with the KBS. The KBS is the one who's really watching over your entire workload. And the KBS will say, that looks good, or, oh, that's not correct. And it also uses a couple other components to do this, but we won't get into that. Then, if the attestation checks out, it will give your keys back. Your keys will go to the CDH, and then the CDH will give them to ImageRS. ImageRS will use them to decrypt the container image, and then, you can proceed to live your life. Container image encryption keys are just one possible secret. We also allow you to just arbitrarily request secrets from the container image itself. So you can connect to the CDH from inside of your workload and say, like, oh, I want the key to connect to a database or something. And it will then get that.
Cool. So the confidential data hub and the attestation agent work together to get the hardware evidence to like from the guest, and that, but by creating that hardware evidence, then they set up a secure connection with the key broker service. So the key broker service is just running somewhere else, far away, and they receive the evidence from the CDH and they verify it, and then somehow the key's released. But I'm unclear about who's doing that.
Yeah, the KBS generally, I'm simplifying here a little bit because there's actually, the KBS is actually involves 3 different components. But we have an OPA-based policy that you can set up in the KBS to evaluate the evidence and say, okay, I want to release this secret in these cases. So you get the evidence, and then you look at it.
Release.
And that is an enormous simplification because validating evidence is actually an extremely deep and interesting thing. But yeah, you validate it. You can have this policy that a guest owner can set to be whatever they want, and they can say, okay, only release these keys to this guest or something like that.
So the KBS releases the keys?
Yeah.
Okay. When we say the CDH gets the hardware evidence from the guest, that's the same as making the attestation.
Yeah, essentially.
Okay.
The attestation typically happens at boot sometimes. Like a lot of these hardware platforms measure how the
Mm-hmm.
guest boots. So part of the attestation process happens at boot when the guest is first starts. Certain things will be measured. Actually, it's before boot. And then this phase is when you get the report. So usually the report is already set in stone at this point, but then you retrieve it from inside the guest.
So I think you seem to have so much to say, and I'm loving every minute of this, but we're running out of space. So we talked about like the big takeaways are the Kata doing the work of the VM with one pod inside, and then Coco doing the work of making sure that the image is pulled from within the VM and not from the host, and then Coco doing other work to make an attestation, get that attestation verified, and then get the release the keys to be able to run the image. The keys do what? Run the image?
Well, for an encrypted image,
Okay.
the layer blobs will be encrypted, and you cannot unpack the image without having them.
Releases keys to unpack image. So we have an image, but it's not accessible.
Yeah. But again, we support any arbitrary kinds of secrets. So you might, from inside your workload, be like, hey, I need to connect to this database, so I need certain credentials to do that. And you get them. We also support integration with Kubernetes secrets,
cool.
which is actually maybe a good way to sort of tie up some loose ends here. Because I think that we've covered now 80% of what Coco does, right? Like these are the big ideas. We put the pod inside of a confidential VM, we pull the images inside of the VM, and then we do attestation, right, to provide secrets. That's like a huge amount of the project. Believe me, there's a lot of details, but that's a big. The secrets thing. Well, I'll let you write this bit down.
Okay. Decrypt image, get secrets, whatever.
Yeah. Oops. Secrets in general.
Okay.
The thing about Kubernetes secrets, I think, comes back to a question that you asked at the very beginning, which was about how your project interacts with other CNCF projects and where it sits in the whole landscape and all this stuff, right? And there's something very interesting about Kubernetes secrets here. Like I said, we don't trust the control plane of Kubernetes. You do all this messing around to attest all this stuff. We don't measure the control plane of Kubernetes. So we basically assume that we have no clue who is running that and that we don't trust it at all. It could be doing anything. But that means that there are some even security-related things that the control plane will do for some workloads that we're not going to be making use of. For instance, some people will use Kubernetes secrets in their workload, and they'll be like, okay, I've got my super secret password stored away in this Kubernetes secret. Now it's going to be mounted into my VM, or maybe not a VM. It's just going to show up in my pod in an environment variable or whatever. Well, hopefully it's somewhat clear why that sort of approach wouldn't really fit with the confidential containers model, where we don't really trust the control plane to do anything. And the last thing we would want to do is give the host our secrets. That's sort of the entire point of the project, is to not do that. Now, we do actually support integration with secrets. But I think the thing that I'm getting at here is, like I mentioned earlier, most software is not built with this confidential trust model in mind, like I said. So when you go to run complex workloads, you may need to think some, is this connection I'm making here, is this thing I'm talking to over here, is that going to be confidential? Am I violating the trust model? Usually, there are ways to reconcile these things. And with secrets, for instance, what we can do is we can take a Kubernetes secret and encrypt it, right? So the control plane thinks that it has a secret, and it does, but it can't actually read the real secret because it's wrapped inside of something. And then when we show up in the guest, and we have support for this in the CDH, by the way, when we show up in the guest, we can say, oh, here's a wrapped secret. Well, if we want to use the secret, we need to get a key from the KBS, the thing we actually trust, that will unlock this. So in the CDH, we do support sealed secrets transparently. They show up in an environment variable. They work just the way you would expect, but they have to be sealed secrets to be protected from the control plane. And I think that's just a good example to mention because it opens up a lot of ideas about how we relate to other CNCF projects, about how you run real complex workloads with confidential computing. It's a long way from the Hello World example.
Yeah. So yeah, that makes this has me thinking about Kubernetes security from the angle of when am I trusting the host? What am I trusting? When am I trusting like the machine it's running on? When am I trusting the control plane versus like what you said, like data and rest or data and motion. So I'll be you're changing my brain. Like as I review all the other security projects, I'll be considering that angle that I hadn't considered before. So that's cool.
Well, and that's why there are many ways to integrate with a lot of other CNCF projects. There's a lot of really good crossover, but there are also other projects where it's like, there's a lot of security projects are rooted in the control plane. Like that's the whole point, is that the control plane will enforce X, Y, and Z, right? Okay. For us, we don't trust the control plane. And for confidential computing, you don't care at all what's happening on the host. It doesn't matter. So not only can we not rely on what the control plane might enforce, but we also don't care. So that's one way in which confidential computing, in some ways, is like very related to something like a zero trust model. Like in some ways, those things are like deeply related. But at the technical level, there's sometimes a mismatch between how these things are actually implemented. So, of course, it's a little more complicated than that, and it's really best to think about it on a case-by-case basis. Confidential containers right now is really trying to reach out to other CNCF projects and build more bridges to other security projects. So if you are sitting there with a security project thinking, what did you just say? They don't want to use X, Y, and Z. Like, actually, we should look at it and think about it in a case-by-case basis. Because usually, like with the secrets, there is a way to fit these pieces all together and to reconcile these things. But it usually takes some thinking.
Yeah. Cool. Well, we still have this much space.
Yeah.
What other idea do you want to impart, or what have we already talked about that you want to clarify, or do you want to wrap up and say benefits?
I don't know. I think we've covered a lot. Is there something that's still is there anything that is still unclear on your end, or?
I think maybe if we have this space, maybe a diagram's in order. What do you think?
That's a great idea.
Okay. So what I'm saying is basically we have a virtual machine and then there's a lot happening in the virtual machine. I guess we have like a kubelet outside and like a Kubernetes outside. So let's try, let me look at my space. So, all right, something like that. Finding more room up top. Okay, so below, so this is our VM, and our VM is running on Kubernetes.
Oh, actually, there is one thing that is important that we get to.
Okay.
Which is just, I like the diagram plan, but let me just mention one thing before we get to it, which is what I was saying about what to do if you don't have the hardware. Right. And since we're out of space, this will just go into the ether, but it is really crucial to mention that we do also have a way to run these things with cloud integrations, which obviously is extremely important. One interesting quirk of confidential virtual machines is that they very rarely support nested virtualization. So if you are in a cloud and you have a virtual worker node, you're going to have a hard time starting a confidential virtual machine inside of that. Some providers will support that, but for the most part, not supported. So it's a little bit of a can of worms to have, well, how should I put this? Cloud integration with this stuff. We've thought a lot about the best way to do it. And what we have is a model called peer pods, right? And this is basically an answer to what you would do if you wanted to take the entire thing that you're drawing and put it inside of a VM. And basically,
Oh.
and like I said, this is tricky because we don't really support nested virtualization. So if you put this entire thing inside of a VM, when the catashim goes to start another VM to put things in, it wouldn't work. So instead, what we can do is the catashim will not use a local hypervisor to start the virtual machine. It will basically make a phone call to a cloud service provider and say, oh, can you start a VM for me that looks like this? And this will then be a confidential VM. Like I said, most CSPs already support confidential VMs in some way. So yeah, basically what I'm getting at here is there's a way, it's called PeerPod / the Cloud API Adapter, to have a virtual worker node that will then go and start the individual pod VMs, not inside of this existing VM, but as peer VMs that are confidential, that are running in the cloud. And this is how you use confidential containers with some existing confidential cloud offering if you don't have the hardware, right?
So the look and feel of it from a user perspective is like the VMware is running in your cluster, but really in terms of when you get to the physical machine level, there's a different physical machine running for that confidential workload that supports the confidential computing model.
Yep, it's the same model. Essentially, everything is more or less the same, but the pod VM is not running in your worker node, it's running in the cloud. And hey, since it's confidential computing, it doesn't matter where it's running because you have, cryptographic proof about what is running inside of it.
So we have our confidential computing enabled hardware. We have Kubernetes. And then this is our VM. Oops. I just made it tell you it's the so our VM is also called, the catashim's running here in Kubernetes. Okay. So that we're calling this the VM and it's also the guest.
Yeah. Or the enclave.
So we have
or the
enclave realm. Yes. So I'm going to shorten Kubernetes so I can fit my catashim here. So this is Kubernetes. And then this is running a catashim, and then like the kubelet or whatever, and the control plane. Yeah. So we'll just put kubelet. So when a kubelet is instructed to make a pod, the catashim takes that and says, no, I'm going to make a VM instead, and then makes the VM, and then in the VM, they then put the pods in there. So the workload pod, how many pods am I going to draw so I can?
Well, there's only one pod in the VM, but there might be multiple containers.
Where's the, okay, so all of this like snapshotter and whatever else is inside the workload pod?
No, that's inside the VM. So the VM will have all these components that we provide in it, and then it will also have one pod.
Okay. So how many components are in the VM besides the pod?
Well, there's the Kata agent. That's probably the most important one. There's ImageRS. There's the CDH, and then you can skip the attestation agent. You can just say the CDH. So you could say there's 3.
Plus the workload one.
Yeah, so plus 4. The actual pod.
Okay, so I'm gonna draw 4. Okay. And then outside of the pod, we also have our key broker service, which could be anywhere.
Lives somewhere trusted, which could be on your local machine or in a data center, or you could have a third party that you trust to run this for one reason or another. So, but somewhere you trust.
Okay. Key broker service. In a trusted place. So then we have our workload pod. We have our kata agent. We have you call image RS or
Yeah, image RS.
snapshotter.
The snapshotter is on the host, so they
Okay.
skip that in the diagram, but it's okay. It's
Okay. Talks to.
and then the CDH, the confidential data hub, would be the last.
CDH.
Yeah, and we are leaving a couple things out here, but this is a reasonable picture, I think.
Okay, excellent.
Then just draw a ton
So
of arrows between all the stuff.
I know, just scribble it. So the Cuba wants to make a workload and just regular, and the Cuba thinks it's going to do it in the regular way, but the Catashim's like, no, instead, I'm going to make a whole VM and I'm going to put a Kata agent inside of it. And so then I'm a Catashim, I make a VM, I put a Kata agent in there. And now anytime the kubelet wants to do anything related to the workload pod, I'm going to do that. I'm going to forward those requests to my Kata agent in the VM, and I'm going to do all the workload pod things that need to get done to get work done and connection and all the things. But the problem is the workload pod's not running yet because we don't know if we trust it here enough yet. So for one thing, we don't trust that to pull an image outside of our VM. We only want to pull it inside the VM. So we're going to use image RS. So there's a snapshotter on the Kubernetes level that I didn't talk about. But the kubelet wants to pull an image, the snapshotter is the one who takes that request and is like, no, we're not going to pull it out here. I'm going to forward it to my buddy on the inside to image RS. And then we're going to pull the image from inside our VM because we trust it in there. Because we do not trust the control plane. We don't want any of y'all doing anything out here. So then we're inside the control plane. Image RS pulls the image, but the image might be encrypted, or it might need other secrets from the outside world to run it, maybe to connect to it, whatever. And so to get those secrets, that's where the confidential data hub comes in, who's working together with the attestation agent. And both of those are running on the VM. What's this? We can just put the attestation, we can just throw it in there. And they're working together to attest the environments that they're currently in and to establish a connection with the key broker service. So to attest where they are, they're working to get hardware evidence that where they are is safe and it is where they think it is, and lots of complex stuff that we didn't talk about, nor do we need to understand at this point, or maybe ever in our entire lives. And and then once that attestation is made, then we set up a secure connection to the key broker service that's running somewhere else entirely in a trusted place. The key broker service receives that evidence from the CDH, verifies it, and then releases keys to unpack the image. And that's when, if it's an encrypted image, that the actual workload pod can be run, and it's now running. It is a confidential container, and it's running in a confidential computing enabled hardware environment. And so now we don't trust that. We never trusted the Kubernetes control plane. And also data is protected while it's running, in addition to being protected in motion or at rest. Yeah?
Yep. And
Heck yeah.
you also didn't have to do anything for a specific platform. So this entire flow runs on Intel, runs on AMD, runs anywhere, and all the stuff we talked about at the beginning about all the details of all this stuff, you don't have to worry about it, hopefully.
As a user, yeah, the user experience is very easy. That's excellent. Okay, so we just, in some way, just did a bit of a recap. I'm going to recap everything on the board. If anyone has any more questions, now's the time. And I'm going to do a quick recap of everything. Maybe I won't go through all of this in such specificity since I just did it. But let's go over the rest from the beginning and see all that we've learned today, which is kind of amazing to go from zero to confidential computing enabled. So before confidential containers, We had confidential computing, but it was very new. And it's also hard to integrate with any environments, including container orchestrators or cloud environments. So confidential containers specifically solves the problem of integrating confidential computing into Kubernetes specifically. So this is a specification for how to add confidential computing at the pod level. Like we're running pods here. And when it was interesting to me that you said you looked into in your research lab, you considered like what is the best? Should we add the confidential computing at the node level? Should it happen at the container level? And after lots of thinking, y'all decided the pod level, and I trust you. But I don't trust the Kubernetes control plane. So confidential computing is a new technology. It has big momentum. There's it seems likely that there'll eventually will be some regulation around needing to have it for highly regulated industries. But it's a big paradigm shift, and it also takes specific cloud computing enabled hardware. So what it does is it protects data while it's in use. So we have mechanisms already that encrypt data while it's at rest, that make it hard to access while it's at rest. It also we have stuff that protects data while it's moving around, like TLS, that sort of thing. But data in use, when it's actually in the memory of while the application is running, it can be seen by the physical machine owner. So how much do you trust your cloud provider? But whoever owns the kernel can see everything. So confidential computing is, it was hard at first when we were having this conversation to come up with a noun. Like it is and then I want to put a noun as my next. So it's a different trust model, but it's also related to hardware. So it's hardware and a paradigm shift, both, like in a paradigm period, both. So in practice, it's usually implemented as VMs with extra layers of security. But you said it could be other things too. We didn't open that can of worms, and let's not. But it cannot. The important thing is that whatever is running cannot be breached by the host. Like whoever owns the physical compute resources should not be able to access the asset that's running. In our case here, a workload pod. This is all complicated and fun to think about and fun to talk about. But what's important to note is that the user experience, it's very easy. So once that hardware is there, that part might be difficult, but that might not be the actual user. That's probably whoever's setting it up in the first place. But like once that hardware is there, you basically run a Kubernetes operator to install confidential containers, and then you add a runtime class to your workload. And then that workload is going to get the confidential containers treatment without you needing to do anything once it's time to run the thing. So the trust model is basically do not trust the host, don't trust whoever owns the kernel, you don't trust them. And also don't trust the Kubernetes control plane, which is running on the host too. Don't trust the host. So we think about it in terms of what's inside the enclave. Like the enclave, there are lots of different terms for the secure place. In our diagram, our VM is the secure place, and we were calling it VM or a guest, but the secure place can be called the realm, you said, or also a trusted execution environment. So that part is the isolation piece of the trust model. But the other very important part of the trust model is the attestation piece. So the owner of the safe place, whatever the safe place is, should know everything about the safe place itself, and then what about the safe place itself, but also what's running. That's a different can of worms. The important part for the model is that the owner of the safe place knows everything there is to know about their own safe place. Then I kind of went over already the kata, but for confidential containers, every workload pod has its own VM. It's a one-to-one relationship. And that's where kata comes in, but we also talked about that
very recently when we went through this whole diagram. And yeah, I think that's everything. I want to just say the big three things that we went through how it all works, but the three takeaways is you put one workload pod per VM, and then when you pull the image that you're going to use to run that workload pod, that image gets pulled from within the VM or within the safe place. And the third important thing is when, assuming the image is encrypted or if it needs secrets or whatever, confidential containers project also takes care of a way to get those in a place that doesn't trust the host in any way or the Kubernetes control plane in any way. And that's a wrap. How do you feel? Is there something you'd like to add?
That's great. That's really impressive. I think you're a great student and a great teacher. And this will really live as I think, a very valuable overview of the project. The only thing I would add is that if you're interested in the project, and actually, I mean, I would expect a PR from you, honestly, at this point. But if you're interested in contributing, stop by. We're on Slack in the Kubernetes or in the CNCF Slack. Uh-huh. It's linked in our GitHub. We have a website. Two things that are really valuable places to come. First of all, our Slack channel, and second of all, we have a weekly community meeting where we get together and we talk about the project, but also about confidential computing and security more generally. I think that honestly, this is the biggest single concentration of knowledge about confidential computing in the world right now. So if you're interested in confidential computing, come to the community meetings. We also look for people to present interesting topics in the community meetings. So if you have some project that might be related, we'd love to have you come and present for 30, 40 minutes to this really interesting group. That's the way to get involved with the community. And of course, we've got a ton of open issues that you can help us resolve. But
it seems like an exciting place to be, for real. It's gonna be great.
Yeah.
So to say goodbye, I'm going to replay the theme music. We're just gonna dance a little bit, and I know you have a musical bone in your body because of your background. So let's say our goodbyes. Thank you, everyone, for joining us today. Thank you, Tobin, for sharing your time and expertise. I appreciate you very much. This was so fun. Yeah, bring it, Tobin. You're drinking some water.
That's the best I can do.
Yeah. There it is.
You got to keep in mind that it won't be in sync anyway. Due to certain latency effects. So.
Bye. Thank you.